Good morning, students. In today's lecture, we will discuss the next minimization technique, that is Quine-McCluskey method. In previous lectures, we discussed the methods such as minimization by using different Boolean expressions, then minimization by using K-map technique, and now third technique is the Quine-McCluskey method. We will start with this technique. As simplification of a Boolean equation by using K-map is a simple method and which is convenient as long as the variables are up to 6 variables. Maximum for 6 variables, we can easily simplify the expressions by using the K-map. But if the given number of variables are more than 1, then it becomes difficult to form a groups and to simplify the given expression with the help of K-map. That's why the W.V. Quine and E.T. McCluskey developed an exact method to simplify the given Boolean expressions with number of variables or multiple variables. That's why this method is known as, from their names, as Quine-McCluskey method, and also we can call this particular method as a tabular method. This method is known by the tabular method or by the name Quine-McCluskey method. Let us start with the basic principle. As the basic principle of this method is that the mean terms are nothing but the product terms which are present in the SOP, that is sum of product. These terms are called as the mean terms, whose binary equivalent differ only in one place, can be combined to reduce the mean terms. For example, consider the two mean terms as ABC and ABC bar. This can be reduced because only C variable is differ. A and B both are same. Only C and C bar, these are different. One variable changes there. That's why we can minimize these two mean terms. The Quine-McCluskey method is based on the reduction principle, which says that AB plus AB bar is equal to A, because A is the common. B and B bar, by using OR law, we can represent B plus B bar as a 1. That's why simplified answer is the A. AB plus AB bar. A is common in these terms and in bracket only remains B plus B bar, and this B plus B bar bracket term is simplified by using the OR law. That's why we get the answer as A. Now, let us discuss the steps which are used to simplify the Boolean function by using the Quine-McCluskey method. Now, first step is list all the given minterms in their binary equivalent. We have to list all the given minterms and we have to represent these minterms in their binary equivalent. Then second step is arrange the minterms according to the number of ones present in these minterms. For example, minterms which is having 0 ones. This is possible only in decimal 0 number or 0 term. Then for decimal 1, it is represented by the binary 1. Means in a decimal 1, we get binary 1 or single 1. Likewise, in decimal 3, we can represent decimal 3 as a 1, 1. Means decimal 3 contains 2 ones. Means in a second term, which we have to arrange the number of minterms according to the number of ones present in those minterms. Third, compare each binary number with every term in the adjacent next higher category. If they differ by only one position, then put a check mark and write in the next column. Then repeat this step 3 for the resultant column and continue these cycles until no further elimination of variables takes place. Next step is we have to list the primary implicants, that is groups of minterms without check marks. The group of minterms without check marks. And last step, select the minimum number of primes that must cover all the minterms. These are the 6 basic steps which are used to minimize the Quine-McCluskey method or to minimize the given expression by using Quine-McCluskey method. Now let us take this particular example as simplify the logic function using Quine-McCluskey minimization technique, and given expression is the function y of a, b, c, d, 4 variable function is given, and SOP terms are summation m in bracket 0, 1, 2, 3, 10, 11, 13, 14, 15. There are total 9 minterms are given. In stage 1 or step 1, we have to arrange those minterms depending on number of ones present in that minterm. A, B, C, D, 4 variable function is given. That's why each minterm we have to represent in the 4 bits. 0 is represented as 4 times 0, that is 0, 0, 0, 0. Then in given expression, 1 contains one number of ones as a single, as well as decimal number 2 also contains number of ones as a single one. That's why these are grouped in the second group. In first group, only 0 is present. In the next group, the group which contains single ones, that is 1 and 2, these are categorized or grouped into the second group. Now third group contains 2 number of ones as decimal number 3, 10 and 12. These contains the 2 number of ones. That's why these are grouped in the third group. Now next group or next category is the 3 ones, that is 11, 13 and 14. And last group is the 4 ones. It is present in the 15. This is first step. Now in second step, we have to compare the mean term present in first group with adjacent or next group's mean term. Means 0, we have to compare decimal 0 to the decimal 1 and decimal 0 to the decimal 2. Means first group mean terms we have to compare with second group mean terms, and we have to mark the 1 bit change by the underscore or by using the dash. 0 and 1 compared, and first bit is changing or different. That's why in second step, the minterm group is marked as 0, 0, 0 dash, and group or minterm pair is a 0, 1. Similarly, 0 and 2 are compared, and we get the term as 0, 0 dash 0 because single bit difference is applicable. That's why 0, 0, underscore 0. This min-term pair is done as 0, 2. Check mark or tick mark we have to assign to indicate first group min-terms. These are compared with second group min-terms. And we get the two groups of min-terms as 0, 1, 0, 2. Now, second group in step 2 by comparing group 2 with group 3 of first stage. Means we have to compare 1 with 3, 1 with 10, 1 with 12. Similarly, 2 with 3, 2 with 10, and 2 with 12. And by comparing, we get 3 min-terms pairs which allow single bit difference, as these groups are marked as 1, 3, 2, 3, and 2, 10. Similarly, from stage 1, third group min-terms are compared with fourth group min-terms. Third group min-terms are 3, 10, 12. These are compared with 11, 13, and 14. Thus, in second stage, we get third min-term pairs group as 3, 11, 10, 11, 10, 14, 12, 13, and 12, 14. Now, last step in second stage is to compare fourth group from stage 1 to the fifth group of the stage 1. Means 11, 13, 14, each min-term is compared with the 15. And we get the min-term pairs in second stage as 11, 15, 13, 15, and 14, 15. This is the second stage in the simplification. In stage 3, we combine members of different groups of stage 2 in a similar way. Now it will have 2 dash elements in each combination. This means each combination requires 2 literals to represent it. For example, 0, 1, 2, 3 is represented by A dash, B dash. That is nothing but 0, 0, dash, dash. Let us see the stage 3 from stage 2, as in second stage, min-term pairs are 0, 1, 0, 2. This 0, 1 min-term pair is compared with second group min-term pair, that is with 1, 3, 2, 3, and 2, 10. By comparing, again, we have to follow the same rule. 1 bit difference is applicable. Means in 0, 1 min-term pair, 0, 0, 0 dash, which is compared with second group min-term pairs, and we can use the combination of 0, 1 with 2, 3. That's why in stage 3, we get the min-term groups as 0, 1, 2, 3 with markings 0, 0, dash, dash. 1 bit change is used, or which is applicable, is used to combine the different min-term pairs to form a groups in the stage 3. Likewise, in stage 2, 0, 2 can be combined with 1, 3, and again we get 0, 0, dash, dash, and min-term groups as 0, 2, 1, 3. Now again, we have to repeat the same process by comparing second group with third group from stage 2. And finally, group 3 with group 4 of the stage 2 to get the second group and third group in the stage 3. And these min-term groups are given here, as in second group we get group of min-terms as 2, 10, 3, 11. And third group min-terms are 10, 11, 14, 15, 10, 14, 11, 15, 12, 13, 14, 15, 12, 14, 13, 15. As in stage 3, in first group, the groups are, min-terms are represented as 0, 0, dash, dash. Means two groups are given, but both groups are one and the same. 0, 1, 2, 3, 0, 2, 1, 3. We can write this group by only one because they contain same min-terms and representation is also same. That is 0, 1, 2, 3. This is the single group from first group of stage 3. In the second group, only single group is available. That is 2, 10, 3, 11. Means we can take this group as it is. Now in third group, there are two combinations from 4 min-term groups, as 1 dash 1 dash is the first group and second one is the 1 1 dash dash. That's why combinations are used as 10, 11, 14, 15. This is the one min-term combination. And second one is the 12, 13, 14, 15. Means we get 3 min-term groups from stage 3 for this given example. This is given here. First point is, if any duplicate terms are formed in each case by combining the same set of min-terms in a different order, these duplicate term must be deleting. Means only one term or single term is applicable instead of giving repetition. Now compare terms from the two groups. If no further combination is possible, as discussed, the process terminates. There is no stage 4 for this problem, as no two members of stage 3 has only one digit changing among them. That's why this completes the process of determination of prime implicants. The rule is all the terms that are not checked off at any stage is treated as prime implicants, and this is indicated directly in the prime implicants table. See here, this is the table of prime implicants. Now let us discuss what is the prime implicant. A prime implicant of a given function f is a product term implicant which is no longer an implicant if any literal is deleted from it. To find a minimum expression, we construct a prime implicant table in which there is a row for each prime implicant and a column for each min-term that must be covered. Then we will place check marks or cross to indicate the min-terms covered by each prime implicant. Now, the 4 groups from the stage 3 of previous slide, these are listed here, and a number of min-terms which are given in the example are marked in a row or written in a row as 0, 1, 2, 3, 10, 11, 12, 13, 14, and 15. Now for first min-term group 0, 1, 2, 3, these min-terms are present. That's why these are ticked in a given row. Similarly for second group B dash C, these are ticked. For AC and for AB, these are ticked. And from these, we can use the terms which are present at a single in a column. Means A dash, B dash, this particular term is present only once for a 0, given minterm 0, as well as for given minterm 1. That's why we have to consider this A dash, B dash. Means there is no repetition. These are present only once. Similarly, B dash, C is present, and B dash, C dash, we have to don't take or don't consider B dash C because it is repeating in each group. That's why we have to skip this B dash C. Now go for the third minterm, that is AC. This AC term is present. That's why we can consider AC. And last one, AB. This is again we can consider for 12 and 13. And this is the final simplified answer or final simplification by using the Quine-McCluskey method. We can consider number of examples, number of problems, and this can be easily solved by using the Quine-McCluskey method. This particular method is the lengthy method, but this is the simple one. Only precaution is required while making the groups or while marking the minterms in stage 1, stage 2, and in stage 3. Carefully, you have to make the groups and mark the groups in a group, different groups. Okay. Next topic we will cover in the next lecture.